Hello, everyone. Okay, before I get started, can I just say, today has been awesome, right? Everybody give a huge round of applause for the organizers. Yeah, it's been amazing. I am so excited to be here and so thankful that I'm able to be here to talk about the opportunity and impact of immersive technologies. And I've learned a ton today because I work a lot in 3D space, and that means that because I'm working on VR, it's not quite a standard if you're familiar with the WebVR or WebXR APIs at all. So it's exciting for me to be here to get best practices, to hear from so many amazing speakers, and to be here with all of you. So as Bruce mentioned, my name is Liv. I work at Mozilla as of about 6 weeks ago. And I have a link up here if you want to follow along with the slides or any of the demos. This will take you to a resource page because I know sometimes it can be hard to read code up on the screen. So if you want to check out that link, you can see some of the resources that I'll have up here and follow along if you choose. So getting started, I'd like to invite you to kind of just take a second to think about what is your idea of what the word immersive means. For spatial computing or virtual and augmented reality, you'll hear a bunch of different terms, and throughout the talk kind of see that we have a little bit of a naming challenge with virtual and augmented reality. We think about immersion as being able to step into a space, but before we even get into those devices, it's important to think about what we mean when we think about immersiveness. For me, sometimes if I'm reading a really good book, I'm immersed in that world. Or if I'm playing a video game and I'm being another character, I'm immersed in that world. So today, when I'm talking about immersion, I'll be talking about virtual and augmented reality devices. And so when I use these terms, within the industry, there are a lot of different acronyms and words, so I'm just going to kind of give you my take on this to get us all on the same page. Virtual reality aims to transport the user into a digital environment via some very stylish faceware. And augmented reality aims to integrate digital content into the world that we have around us in a physical sense. But if we take a step back from these technologies, just for a minute, think about all the ways that we're already immersed in technology. Just within the last decade, we've seen the ways that technology can grant us these new capabilities as humans that we didn't have before. We have access to the entire global knowledge system in our pockets, or almost all of that knowledge. There's still a lot to be done to get access and people connected around the globe. But compared to where we were 10, 20, 30, 50 years ago, the fact that we're just kind of all casually carrying around these devices that keep us connected to so many people, regardless of where they are in the world, is no small feat. And when we think about virtual and augmented reality technologies, we get to take that a step further. And we get to start thinking about what kind of relationships, what kind of content we get to create when you think about connecting the entire 7.5 billion people on the planet together and give them the ability to be co-present in spaces, to collaborate on new ideas, to teach one another, to talk to one another and share histories and stories. And that's a superpower. I'm here in front of all of you today because I flew out here from San Francisco, but in the future, with these technologies, someone doesn't have to be geographically located with you. And you can start to think about the power that that has in enabling what we as humans are able to do together. So it wouldn't be super compelling if I was like, yeah, VR, AR connects everybody, you can be co-present. End of keynote, although it might get us to the after party a little quicker. But what we'll cover today are a few things. I'm going to talk about today's virtual and augmented reality devices and some of the vocabulary that we use to talk about what capabilities each of those types of devices grant us. I'm going to talk about the immersive web and why, in particular, having virtual reality and augmented reality technologies available to us in the browser is so important for the success of the industry to move forward. And I'm going to show some demos, because I love demos, and it's really fun, and nothing's ever gone wrong trying to do live demos on stage with stage Wi-Fi. I have to say, huge shout out, the Wi-Fi here has been amazing, so hopefully everything will go smoothly. And then I'm going to talk a little bit about how people are using VR and AR technologies today, and how we, as creators of these technologies, need to think about the ethical considerations of what it is we're building. Because if you've seen a movie like The Matrix, you know that there are some scary stories out there around immersive technologies. So with that said, I'm going to jump into talking, getting too excited, about virtual reality. There's some acronyms, there's some similar names. I'm going to start out with just a few of these. So as you saw in one of the earlier slides, when you're in VR, you're wearing this giant thing on your face. And we call that a head-mounted display because it's putting a display of a virtual world in front of your face. And we abbreviate this to HMD. This isn't the only type of virtual reality hardware that exists today. You may also experience a cave VR system, which is where you have a room set up with screens that surround you in all 360 degrees, and you can turn around and have these virtual environments projected around you, not having to wear things on your face. These types of systems are a little bit less common when we're talking about developing for today's VR applications, but a lot of the principles about designing and developing for HMD-based VR still applies to cave VR systems. And cave VR systems offer benefits when you can't, for whatever reason, wear an HMD on your face. When we're thinking about specific types of virtual reality devices, there are different capabilities that hardware can have depending on the features and the sensors that are in the headset themselves. So generally, we categorize these headsets as how many degrees of freedom they have. At the baseline, all VR headsets have a rotational 3 degrees of freedom because they can track which direction you're looking. If you were wearing a giant screen on your face and it didn't update when you look around, which happens if you're debugging stuff and you messed up something with your rendering loop, there's no reason to wear it on your head. When you add additional sensors to be able to track things like if I'm reaching out and grabbing something, or if I'm moving from over here to over here, we talk about these as having positional tracking as well, and these headsets have 6 degrees of freedom. And then beyond 3 and 6 degrees of freedom, we also have the concept of tethered and untethered headsets. So this shows some of the different types of headsets that are available or soon to be available by different hardware manufacturers today. And they're broken out into 3 degrees of freedom, 6 degrees tethered, and 6 degrees untethered. An untethered headset means that I could put this on, walk around, and I don't have any cables connecting me to the computer. Everything is being powered entirely from what's on my face. There are some trade-offs when you consider the benefits that you get from being tethered, which is that generally speaking, a tethered headset is going to give you a higher quality graphic environment because it's being powered by an external desktop GPU. But that said, a lot of it comes down to the types of capabilities that you want your application experience to have. There's no right or wrong answer for which of these headsets make the most sense that kind of globally fits all applications out there. So moving into augmented reality, there's a few different things that we need to think about when we think of AR. So AR headsets, like VR headsets, can also be wearable. Examples of this are the Microsoft HoloLens headset or the Magic Leap headset, which, like a virtual reality tethered headset, have displays that you wear. The HoloLens is untethered, the Magic Leap is tethered, and it projects digital content into the world around you. These headsets tend to consider themselves not pure augmented reality, but a term that we use for mixed reality that talks to the fact that these headsets are able to get an understanding of what your physical environment looks like and then allows you to create digital content that interacts with the physical environment. Some types of augmented reality, like if you've played Pokemon Go, or if you've seen any kind of marker-based augmented reality, these types of applications can generally just overlay data in front of the world, and it doesn't really care about being physically placed in your physical environment. That information is just there. Again, no right or wrong answer. It all depends on the type of content that you want to be creating. I mentioned marker-based augmented reality. This is kind of the most straightforward form of AR, and I'll show you actually a live demo in just a bit that demonstrates this. And it allows you to use some kind of picture or code in the environment to create augmented content that shows up when you point your camera at it. This is often found in what's called a magic window augmented reality application, which can, again, be done on your phone instead of being on a headset. This is a lot more accessible in terms of augmented reality content because you don't need glasses that cost upwards of thousands of dollars to display the content on. So when we think about how all of these systems, the display is just one part of it. The display is what's showing us the virtual content and the digital information that's in front of us, but we need some way to interact with it. For VR devices, hand controllers tend to be the most common route forward for input. It allows users to pick up and interact with virtual objects in the space. It's tracking where their hands are, so if I'm in an avatar in a social environment and I wave, you'll see me wave. But that sort of stuff isn't necessarily required for an augmented reality experience because you may be able to just see my body moving. So augmented reality headsets tend to move towards gesture instead of having tracked controllers because it allows you to interact and move things around the space with and they're holograms, essentially, which is a fun buzzword, but it kind of stuck, and lets you move and interact with that digital content in a way that feels as natural as it can to be moving around objects that don't actually exist. When we think about designing and developing for immersive technologies, it requires a shift in how we think about the content and information that we're displaying to the users. So this is a 3D editor for virtual reality spaces. It's one of the projects that we're working on at my team at Mozilla. And you basically start to think about the fact that instead of having just one device window or multiple displays, if you have a couple of monitors, to display information to the user you're now presented with the entire 360-degree field of view that you can have if you turn around. You have all of this vertical space that's available to you, and you have to start thinking about what that looks like in terms of placing objects in the environment, placing menus, and you have all of this new space available to you to work with. And that can be either really awesome, if that sounds like an exciting problem space, or seem a little bit intimidating. But we as humans are naturally drawn towards 3D interactions because we live in a 3D environment. So generally speaking, when you consider this, you'll think about things from the camera's perspective, because this is what's going to serve as the user's point of view in your space. This is a little representation of just how you might think about placing environment objects at a further place back from a user. You'll work in 3 axes instead of just having an X and Y coordinate system to work with. And you can place objects and move them around the scene, and you want to think about what that looks like in relation to the viewer and how they're going to be experiencing that content. So why bring the browser into all of this? I don't think I would have to sell you on the power of the web. Even if you, for some reason, came to a web conference, not so sure that the internet was kind of a worthwhile place to develop or build, I think today's talks would have probably shown a lot of that. But I'll continue here anyway. Being able to build applications that run across different devices that probably, if we're being honest, don't all exist yet, is a really powerful thing that the browser offers that you can't get automatically if you're developing native content for virtual or augmented reality. There are a few tools and frameworks out there that aim to unify development for different platforms, but they're not as ubiquitous as the web. There's not standards, and that's one of the benefits that being able to work in the browser gives you. It's connected inherently. If you've built native applications and tried to integrate web services into them, that can sometimes be easier for some things than others. But with the browser and building browser-based immersive applications, you get a lot of these benefits of the frameworks and libraries that are out there, and you can already have this ecosystem with which to build content from. And the web is powering a lot of services, even in native virtual and augmented reality applications, but I'll get to that a little bit later. And then, again, I already kind of touched to this. It's really nice to develop for the web. I'm just going to say it, having done both. You get all of this access to this community that is building with shared languages, shared frameworks, shared understanding of the platforms that you're ending up on, which helps a lot because virtual reality won't succeed if everybody has to be an expert games programmer to create content. And that's the state of what a lot of virtual and augmented reality applications have been up until this point. So my experience, actually even learning JavaScript to begin with, started back in 2015 when Mozilla and Google were just starting out with this proposed standard for the WebVR spec, which would unify development for virtual reality devices across browsers. At the time, you had two headsets to choose from, the Oculus Rift or the HTC Vive, and I saw the power of virtual reality, and when I heard about this kind of new initiative that people were starting to think about, it made the most sense to me that this would be a natural way for VR to be presented. So back in the 90s, there was an attempt to kind of lay the foundation for virtual reality applications on the web called VRML. And at the time, it didn't quite stick the way that the VR web ecosystem has kind of developed this time because devices weren't as readily available, and the internet didn't have as wide-scale adoption as it does today. So when we think about the differences here, I think I jumped past a slide that I meant to have. When we think about this today, as I mentioned, we're kind of in a little bit of a naming rut with the immersive web in terms of the new standard that's been proposed, which is the WebXR standard. And this is currently in the Microsoft Edge browser and Chrome browsers behind a flag and in Firefox all up. But the idea behind the WebXR spec is that you're able to surface immersive device capabilities to websites regardless of whether they're virtual, mixed reality, augmented reality devices. And all three, Mozilla, Google, and Microsoft, have all committed support to the WebXR spec. So there's also this question when we think about bringing VR into browsers as they exist today, what it means to be a browser when the web becomes more 3D. What does it mean to browse websites in virtual reality or augmented reality? Do you just have a window that's floating in space in front of you? How do you represent different tabs? What does a hyperlink look like? How do you move seamlessly from having a 2D website on your computer that works seamlessly in 3D? And so these are just some of the questions that the WebXR spec and some of these companies working on the web are starting to explore today. So with all of that said, let's start the part of the presentation that has no risk at all, and let's jump into demos. So when I started learning JavaScript specifically so I could start building for WebVR, or what was at the time WebVR, I made this little demo that I called Hello Taurus Knot, because it's a simple representation of a mesh geometry in VR. And as I was making these slides, I came to the realization that it's actually really hard to show what a VR application looks like when this is a giant screen. But I do have a couple of videos that I'll show for some of the demos, and then I'll walk through the code to kind of explain what we're doing here. So just to give you a sense of this demonstration, this is a remake. Oh, it doesn't look like that once. There we go. You get the idea. This is a remake of the original demo that I did back in 2015, and the Glitch project that is hosting this has a copy of the old code. So if you want to look through that on your own time later, you can see how much it's changed from 2015 to today. So with that said, I'm going to jump over, actually I'm going to jump back to my slides, and then come over here give you a little peek of what that old demo looks like, but I'm not going to go into this because this is 4 years out of date and wouldn't be very helpful if you wanted to start learning today. So instead, I'll show you here what this looks like, and let's see if I can make this a little bit bigger. Excellent. So we have two main components of this demo. The first thing that we're doing is initializing our scene, which is what contains all of the content that's going to be used for this application. In this example, this scene is not particularly complex. We have a camera, and we set the camera's position to be about 2 meters, which is a little bit taller than me. Generally, you might want to place this a little bit shorter, but this aligns with the player height or expected average player height in your application, because remember, you're developing content for someone to be standing inside of. I will tell you, standing inside of that demo is a little rough. This was before I learned a lot about what simulator sickness was like. So if you have a VR headset and choose to try that demo out, please do so at your own risk. So we create a scene. We're using the Three.js library, which helps developers build graphic content using WebGL. So we create our scene. We create a torus knot. We create a material. We make a mesh by combining both of those things, and then we add the mesh and the camera to the scene. So the object that you saw was only two items. After we initialize our scene, we initialize the renderer, which is what's going to display everything, either on the website in front of us in 2D, or on the display in your headset stereoscopically, or twice. And we're going to set our renderer to have VR enabled, and then we'll add our canvas and the WebVR button to the DOM, and then we will render it. And our animation loop will move our torus knot, because it's not just enough to be like standing inside of a giant rainbow mesh. It should also be spinning. And we also will render and update our scene. So I used a VR emulator to capture the video that I showed you. But if we take a look at this now, you can see here's this demo, this whirling demo in all its glory, and the sad VR not found button, because I don't have a VR headset up here with me. So Three.js is a very, very powerful library, and it's also the base of a number of different libraries that are available for building virtual reality content. So I actually made this demo twice, once using Three.js and once using A-Frame. A-Frame is a markup style language that wraps around Three.js. So if you don't want to work directly with the Three.js components, you can do a lot of powerful stuff using A-Frame instead. I say instead, it's wrapping it, so it's kind of both, but you understand. So the bulk of this implementation, which is, again, exactly the same, if I come over here and show you aframe.html, same spinning blur. This is actually only about 20 lines of code, and most of that is because I had to import the material because it's not standard in the A-Frame components. So if we come down here to just the core of it, you'll see that how we defined our scene is a little bit different. We now have these tags that are prepended with the A dash, as in A-Frame. And we can have in our body content, we have our scene, we put our camera in our scene, we put our torus knot in our scene, and then we're done. So it's a very quick way that we can get in here. We can look around our scene. Sorry if that's a lot in the audience. I'm not going to move that anymore. But you can see two different ways of accomplishing the same goal with creating 3D content. So that aside, let's jump into something that's a little bit more interesting to look at than just a swirling rainbow. I mean, it depends on the kind of mood you're in. So if I jump over here, I have another video, but it looks like my movies and TV app only lets me open one at a time. So bear with me as I open this up. So again, this is using the emulator. This is an application that I built that shows pictures from the International Space Station as if you're floating in outer space. I'm a huge fan of astrophotography, and this was a really fun environment for me to make so I could just sit down and kind of zone out, look at these pictures, and feel like I'm kind of getting the experience of floating. So if I jump back here just to kind of show through a little bit, you saw a little bit of the rotation in the emulator. The emulator is also doing some positional tracking just to give you a sense of what it would look like if I were to be walking around the space. So I want to call that out specifically. So if I come back over here, again, this is the site. We'll take a look at it in Glitch. It's more involved than the first demo because there's a lot more content in the scene that we're rendering. I'm going to see if I can make this a little bit easier to read. But again, all of these are linked in the resources site. So if we come back down here, we're importing Three.js and WebVR again. This is also built with Three.js, but you could build this with A-Frame as well. So again, we're going to go through a lot of the similar things that we saw in the first demo. We initialize our scene. We create a camera, create our scene. This time we're adding audio. And in immersive applications, audio is super important because it really grounds you in terms of representing what it's like in the physical world, because it is very, very rare that we're in a totally silent place with no noise. So we have the opportunity here to add multiple types of audio. This is ambient sound, so it just plays around you all around, and it's supposedly a sound file taken from the waves or Saturn's rings. I don't know how Saturn rings audio is captured, but it sounds kind of cool and like creepy if you listen to it, and take a look at the demo on your own later. The other type of sound that's really important in immersive applications is positional audio, which is if I made, let's say, a bird in a tree, I could have that bird chirping, and the positional audio will sound as if it's coming from the tree, which I've decided is over here virtually. Again, very important for context cues and grounding a user in the environment. So we add the volume or the sound to this. We load that in, add it to our scene, and then we call this function add objects to scene, which I just added to break up this wall of text just a little bit. So again, we go through, we create these different meshes. We create meshes for the planet. There is a moon. I'll switch back to here for just a second so maybe we can see the moon. It orbits around, so you might see it come up over the horizon. We're adding meshes for our planet here. We're adding a mesh for the pictures, and then we load in different textures for the pictures so that if I were to come over here and like, whoops, change, I think I have a button pressed somewhere on my keyboard. Hello? There we go. So I can go through and change some of the different pictures here. So we're loading in textures, which are part of the material that's on the object. And there's the moon, right on target, right on schedule. Also a sphere, just with a different texture than the one that the planet is using. So both of these examples just use primitive geometries to create objects in the scene. So even before you get into 3D modeling or different types of assets for your scene, you can get pretty far with materials, textures, and primitive objects. So we add our planet in. We add in a skybox, which is surrounding the entire scene so that it feels like you're in space. It would be a little bit weird if you were just seeing like this giant plain white wall around you. So we add in a skybox texture. And I'm not going to go through all of this in too much depth because a lot of it is very similar. We set the position and sizes for the geometry. We load in the textures, and then we add it. And once our scene is all set up, we, again, go back to our renderer, and we render our scene. So the next demo I'm going to show you is particularly near and dear to me because it's the it's the product that I get to work on full time now at Mozilla. Before I joined Mozilla, I was at a VR startup working on social VR. And the social element of virtual reality is really what stands out to me because as I mentioned at the start of the talk, that's the part of this technology that's really changing the way that people can interact with each other and is one of the most powerful uses for immersive technologies. So we work on a platform called Hubs, and Hubs is a social platform that works on, as you're about to see, mobile, desktop, and VR devices. That's another really powerful thing about the web is that it's automatically assumed that you need to make content that works on all of these devices instead of just building your application that targets one specific headset on one specific platform. So in thinking about that, even kind of from the design of these applications, designing for the browser gives you a lot of flexibility in terms of thinking about the most users that you can empower through building these applications. So I have a room here, and I think my tech lead might freak out a little bit if he knew I was doing this. But if you want to jump in on your phone, and this is a first, so we'll see how it goes. You can go to hub.link/UN4SWOZ, and I'm not going to keep that up too long because I haven't actually seen this with more than like 20 people in it or so. But I see some of you are starting to join the lobby. So I'm going to just jump in here. This is the default scene. I'm going to enter on the screen because, again, I don't have a VR headset with me. I want to mute my microphone so that if you do jump in with your phone, you're not going to be like hearing me both ways. So inside of here, I can run around. I have an avatar. This is my other tab that I have open on my other Firefox browser. So I'm both of these. And I've made a little sign and a little picture here. And what I'm going to do is just kind of give you a brief overview of why avatar-driven communication, in my opinion, is a super compelling use case for virtual reality. So I mentioned being able to connect with people from around the world is a very, very powerful thing. I think what is it, something like a third of the attendees are international here. That speaks to the power of having community and being able to be present with them. So when we think about being present, oh, you're finding the chat, with people, you know, all of us right now are co-present in this room, but last night after I went to the speaker dinner, I actually jumped into one of these rooms to have stand-up with my team, even though I'm 10 hours ahead of them. It felt like we were all still physically co-present together because we're all in avatars. And I didn't have to change out of my pajamas because it was late for me here because I'm an avatar and I'm not on video. So in here, you saw me moving around a little bit earlier. You've discovered the chat. A few of you are jumping in. The power of the web and being able to bring in everything you want. I hear basketball is very popular. So let's see if we can find like a good video. So here, look, this looks like a, why not? I'll go ahead and spawn that in. This is the part I didn't test on the Wi-Fi, but it seems OK. So you can see I've got a video in here now. I love that people are chatting. That's awesome. And so this video is over here playing. I'm muted. I don't need to have audio that I'm competing with right now. But it's a really powerful way to kind of get together to immediately be able to create content. I can jump in here and create 3D models. We like rubber ducks, so I've got a little duck over here. And it basically is just kind of the start of exploring this avatar-embodied communication and collaborative abilities that you can have where, again, I'm in desktop right now, but I can also be in VR and do all of these things and communicate in different ways. And that's, to me, something that's really, really critical about immersive technologies is that so often we think about it as an either-or thing. We're thinking, it has to be a VR or an AR app. It has to be fully immersive 100% of the time. Our users will always be in a headset. Someone found the avatars. And that's just not true. We have different identities depending on the platform that we're in. And we have different capabilities that we need depending on the scenario. And so it doesn't make sense to always assume that for a communications platform that incorporates virtual or augmented reality, we always expect people to be in one of those modalities. So when I think about immersive web, it's this combination of devices. It's thinking about new ways to interact with each other all the time, not just when we're in a particular mode. So I'm going to go ahead and close the room. Thank you all for everybody who jumped in here. This is all up online, hubs.mozilla.com. As I mentioned, it's also all open source. So if you want to check it out more, play with it. If you ever want to have a meeting with me, I'm happy to jump into Hubs and we can hang out as avatars. But before we go, I'm just going to really quickly take a selfie so that we can remember the occasion. So I'm just going to throw this up here. Take a picture. Take a picture. There we go. Yay! Awesome. All right, so I'm going to save that for later, and then we're going to move on to the next demo. Oop. There we go. All right, picture saved for later. Going to close the room. Thank you all who jumped in to help with that demo. That was great. So now I wanted to, I've been working in VR for the past couple of years exclusively, but I felt like I wanted to show you some AR demos as well. So yesterday, I decided to throw together a quick little demo, again, using A-frames, so similar to the Taurus knot demo that you saw earlier. Oh, I forgot to mention this. Hubs is also built with A-frame and 3JS, so all those same technologies, but in a much more fully featured, developed application than the ones that I demoed before them. So yeah, I found this ARJS extension to A-frame that allows you to do augmented reality, marker-based augmented reality in this case, again, in the browser. So I'm going to do this demo, and bear with me here, because lighting conditions impact the success of this. Ah, it worked. Perfect. So you can see here, we just have this marker, this image on my phone, and I've got some cool, like, infinity loop going on here. So I'm just showing text, but there's a lot that you can do with QR code or marker-enabled augmented reality that isn't just text. But if we come back here, oh, let's see. I'm glad it decided to do that perfect before or after I showed it. You can see here that, again, we have a scene that we set up. This time we specify that it's using ARJS. And we set up a marker type. So in this case, it's the picture that I had on my phone. You can set up custom markers, QR codes, essentially, I don't want to say whatever you want, but like kind of whatever you want. And then we specify as a child of the marker the text that will show up, or the A-frame entity that will show up when the marker is discovered by the camera. So here, we just have a text value. We have it rotated so that it aligns with what we would expect. I made it a color to match my slides. And we're essentially set. I mentioned 3D models earlier. So I want to really quickly change this and show you, because again, like text in VR is definitely needed for some cases, but it can also be fun to explore 3D models. And other than hubs, none of my demos had 3D models. So I commented out the text line of code, and now when I use my marker, you can see my robot. This is my work in progress avatar for hubs. You might have seen the variation when I took the selfie in there. This is a GLTF model, which is a 3D model format that's standardized and extensible. So you can add a whole bunch of cool information to it. And it was kind of designed with portability, extensibility in mind. So super powerful. All of the scenes that we build in hubs use GLTF files or their compiled form GLB models. And so yeah, we just say, follow the robot around. It's happy. It's dancing. It also participated in Bruce's flamenco classes. So again, yeah, jumping back here, this is all A-frame. Again, about 10 lines of code. Super, super powerful stuff, really easy to get started. So with that said, again, all of these demos are up on the resources page. They're hosted on Glitch, so you can remix them, play around with them, make your own markers, make your own apps, all available up online. So jumping back into here, I'm going to represent my slides. And excellent, it started where I left off. Don't need to go through these too much because we saw the cool part already, but as references later if you're looking at the slides. So again, I mentioned the libraries that I use for the demos, 3JS and A-frame. You can find more information about both of them here. You saw them in action, so I'm not going to talk too much more to that. I also wanted to talk about a couple of these. I haven't personally used either of them, but they're two popular frameworks for building content. So I felt like it was important to also list these here to give you kind of a more complete picture. Again, if you have specific questions about these two frameworks, I will not be able to answer them very effectively, but React 360 and Babylon.js are two other frameworks and libraries that you may find if you start doing some research into building immersive web content. So why are people using VR today? Lots of reasons. I'm glad you asked. So one again, I've mentioned like the social element being really powerful to me. And this is very clear in the case of educational scenarios, because with immersive technologies, you're opening up the opportunity for people to be able to go in and learn in an environment that they literally could not get to, like outer space or tombs that are in Egypt and closed off to the public. But in VR, you can reconstruct these places and have instructors who are experts in their field be present in these virtual spaces, even if they're on the other side of the world, and host classes or lectures about them. So Curated by Kai is one organization that specializes in VR field trips, and you can see just a couple of those here. And it's really, really powerful to see students in VR getting to do stuff like walk around the inside of a cell and see what cell walls are like, because no matter how hard you try, you will never be able to do that in our physical world today. Medical applications are also an increasingly popular choice for immersive technologies, because medical students can use the devices, again, for education, but also use these headsets for applications that assist them in doing surgeries. So you can reconstruct the inside of a patient's arm and understand what their vein system is like, and then wear this headset and look around inside the vein system and get a sense of what you can work with during a surgery, which is really, really powerful when you think about what that entails in the future of medicine. Immersive journalism is another area that VR is really well equipped to support, because it's literally giving you the ability to take someone to a place or a location they can't be in, or at an event that they can't be in because they're on the other side of the world. And right now you can go on Twitter and you can read about these tweets as they're happening, but with virtual reality technologies, you can take somebody to Greenland to show them the effects of climate change, or take them to meet someone and sit face to face with them as they talk about what their experience is like after being released from prison. The Emblematic group is headed by Nani de la Peña, and they're doing a lot of really compelling work in the web VR space around immersive journalism and telling these stories. Professional development is another area that people are able to explore and use VR for. This is a virtual photo gallery that a photographer friend of mine has built to showcase some of the work that he's done in a way where you can step inside, put on a headset, and see these pictures as if they're in a gallery, which you don't get when you're just looking at it on a 2D screen. Architecture is another area that's really well suited for immersive technologies, because you can step inside a building that doesn't exist and make decisions about the wall placement or moving stairs from one place to another. And you can bring in the clients that you're working with and do these exercises together in a way that would be very not cost effective to do after the building has already been built. So architects are using both virtual and augmented reality tools to help them in the design process in building applications and interior design, changing paint colors on the fly. A common application that uses AR is to place furniture around your room if you're indecisive about whether or not you think that something's too big or too small for the space you're trying to fill. On your phone with apps from companies like IKEA, you can place your furniture in the room and see how it looks before you buy it. The National Gallery is one museum that started offering virtual tours. So again, providing the opportunity for people to visit places that they can't be physically is another really good use of VR application. So again, you'll notice a trend. It's a lot of being somewhere that you're not already, or getting access to information that you may not otherwise have. And the museum case is really interesting because it opens up this question of ownership of a 3D scan of content that is currently living in a specific museum. So there's a reported case, and again, this has kind of been like, I don't really think this happened, but it's been reported that someone actually illegally 3D scanned a model at a museum using Kinect sensors, and then reconstructed that model and started offering it to people like, hey, we have this reconstruction of a statue that's in a particular museum. And regardless of whether or not that story is true, it brings up the really compelling case where we need to be thinking about the ethical decisions that we're faced with when we think about virtual and augmented reality technologies. There are a lot of reasons, and this could be a whole other keynote in and of itself to think about, because Information, safety, security, privacy, data protection are all already things that are super important for us to be thinking about in any application that we build. And when you think about virtual or augmented reality, you're adding new layers of things to think about and additional layers of biometric information that is potentially personally identifiable. So one thing that's come up is the destruction of virtual property. So this is a Burger King ad that would give you a free Whopper if you took their app and held it up to a McDonald's ad and showed a picture of it now being on fire. Some people thought, like, oh, this is just kind of this funny little gimmick advertising scenario, but others were, kind of cautionary. They're like, McDonald's probably doesn't like this app very much because it's virtually destroying their property. And when you think about that as applied to buildings or people and being able to put filters on people that they don't know about, or in the future, potentially very incriminating virtual content around a user that's indistinguishable from physical content around a user, there are a lot of questions about how we're preventing those types of scenarios and what we as developers can do to think about how these technologies can be a vector for abuse and stop them before they happen. So there, again, as I mentioned, I could go on about this for a very long time. There are a lot of considerations around, say, digital rights. I mentioned the Burger King ad as one example of this, but there's also just questions about, do we all always have a shared augmented reality layer? For the most part right now, we can all be pretty well assured that we're sitting in the same room, seeing the same building, the lighting is the same for us. And of course, everybody's in here maybe looking at their phone, and I don't know what's on your phone, but that's a very contained and well-understood model for what's in your world at a moment versus what's in mine. But when you think about augmented reality in particular, you have no way of knowing if someone's replaced the screen behind me with any kind of content they want, and I would never know that. So digital rights and the shared elements of these digital spaces is one area that we need to consider. Identity is another really important one, and this ties in with biometrics in many ways. So for one, if you have a tethered 6 degrees of freedom headset, there are cameras that are either in the headset looking out at the world around you, or there are cameras outside looking at the headset to track where you are in the space. These cameras are providing that service of knowing if I'm squatting down or if I'm standing up on one foot. Those cameras are understanding where the headset is in my room, and they're essentially telling me, like, yes, that's okay to do. You're moving around in this space. But that means that those devices now have a record of me in my living room sitting at my desk, getting up, putting my headset on, walking over here, looking at stuff, walking over here, looking at stuff, and they can track movement patterns and they can track gestures when you're using hand controllers. And again, not inherently bad things for a virtual or augmented reality headset to track, but very important information to protect because it is highly personal to how I move in a space versus how somebody else moves in the space. There's also considerations about gaze detection and knowing what you're looking at when you're in a virtual environment. Again, not necessarily a bad thing for the services that it can offer through applications, but something very important to think about, because if you have access to reconstruct a heat map of everywhere that I've looked in this entire room over the course of the hour, well, you'd probably see like a giant spot like right around the back door there. But if you think about that in the context of being able to layer that to a virtual reality environment, you can see exactly where I'm looking the whole time. Again, information that you may or may not want exposed, so it's very important to keep that information private. And again, I'm all in on social VR, but there are a lot of considerations for how people treat each other in a virtual space. We already see how social media platforms can be used in abusive ways, and virtual reality doesn't just magically make all of that go away. You're protected by this layer of pseudo-anonymity behind an avatar, and you're choosing how much of your identity in a virtual space is exposed to people in that space with you. And it's very important for creators to give users control over that identity in their virtual space. There's a lot of interesting psychology behind being in avatars that don't represent how you feel about yourself, and what it means if you can't find an avatar in a social space that feels very representative of you, or the ability to create your own. And of course, with virtual and augmented reality, specifically social applications that use these technologies, other users are now a physical presence in an environment. If I'm reading on Twitter and I'm getting abusive tweets, I have some tools available to me, and I have to kind of work with that. In virtual reality, though, it's not words on a screen. It's potentially in the form of somebody standing right in my space or in my body trying to make me feel uncomfortable, which is a different set of considerations for these technologies. But on the happy side, looking ahead, I still feel so excited as I did the first time I tried a VR headset 5 years ago, about the potential that this industry has, especially when I see the adoption of immersive experiences on the web and moving away from really heavy device-specific apps to ones that are more accessible to a greater number of people. So some of the things that I'm really excited about in the not-so-distant future, because we can all imagine kind of this ideal world, like years out from now, where the hardware is really nice and sleek looking, and it's got really good field of view, and it's very natural, and we figured out all of the ethical considerations. Yeah, I can dream. But looking ahead, some of the things that I'm particularly excited about, new interaction models. Hand controllers and gestures are a great start, and it feels really good to step into a virtual environment, be able to reach out and grab something. But the development of more mature voice inputs and being able to talk and do stuff in a virtual world and making that feel very natural is an area that will open up a lot of opportunity for different types of interactions. And wearables and haptics and being able to put on a glove that lets you feel physical sensations from things in the world is not as far out as it might seem. I've actually tried a few of them, and they're very bulky right now, but the promise of that is there. And that will, again, allow us to interact with devices a lot more naturally. If you've tried VR and tried typing, you know it's really hard. So that's one area that voice and haptics is maybe a little bit more positioned to figure out than hand controllers. Hardware improvements to devices are coming, they're landing, and it's really exciting to compare the number of options that are available today to what was available 5 years ago to what will be available in the next 5 years. As the devices have better quality hardware, more sensors for lower prices, VR becomes less and less of something that you have to have this like super powerful gaming rig to be able to run, and more accessible for people to be able to use for all of these different use cases that I've outlined. I'm excited for more web tech to be in VR. The web is powering things like payments and ads and transactions and social communication. We use WebRTC and hubs for our audio communication. And thinking about kind of this growing ecosystem of the web, which isn't slowing down, being applied to the field of virtual and augmented reality is something that I'm super, super excited about. And developing more tools and frameworks and libraries so people can continue to build for the immersive web with languages they're familiar with in ways that they're very comfortable with will only open up that ecosystem to more and more creators. So with that said, I mentioned here are this link will give you the resources page that I put together. I wrote this talk in my speaker notes as a 15-page PDF, so if you want to just read that and you forgot everything I said, that's up there. I learned during the talks today, I should tell you all that it's about 15 megabytes, and that's on the site too. I learned that from an accessibility talk. The slides will be up there, the demo projects will be up there, and then just some other links that I've posted that I think will be helpful. If you want to chat on Twitter about any of this, I'm Miss Livy Rose. You can also feel free to email me at l.erickson@mozilla.com. I'll be around tonight and tomorrow. And I just want to say again, thank you all so much. This was an amazing day, and I hope you all think so too. And now with that said, I think I'm the only thing standing in the way between us and the after party. So with that said, I'll see you all around and hopefully see you somewhere on the social web.